Okay, so these are the worksheets we've been the worksheet we're working on today, which is on quadratic word problems, formulas, and word problems. All right. Yeah, so we'll get right into it. So first things first, Jason jumped off a cliff into the ocean. Just to clarify, he's sea cliff diving, whatever. And I don't know where that is. Just call it some ocean or some city. Looks Italian. While vacationing with some friends. His height is as a function of time could be modeled by the function h of t. When it says height as a function of time, that is literally saying h of t. Height as a function of time. So functions are the parentheses, height is the variable of h, and then t is the time. Okay? H of t, and here's our function. Okay? Where t is the time in seconds, and h is the height in feet. Okay? So how long did Jason reach, or how long did it take for Jason to reach maximum height? Remember, when we look for the maximum, we're looking using the equation x equals opposite of b over 2a. We want the x coordinate, the vertex. In this case, x, though, however, is t. Opposite of b would be negative 16, yep, over 2 times negative 16. Now, there's a shortcut here. You could just cancel 16s out and get your answer, but if you wanted to multiply it out, you could. You would get negative 16 over 2 times negative 16. That would then give me negative 16 over 2 times, negative 32. So negative 16 over negative 32. And that gives me 1/2 second. And that's my answer for the first. So he jumps up and he's only up in the air for half a second at his maximum height. Obviously, when he jumped off the cliff. Right? Not very long. The next part of the question asks, what was the highest point that Jason had reached? We are now going to take this time, as we've did this a bunch of times, plug it back into the original function to get our answer. So at the height of 1/2 of the function, in parentheses, we get negative 16 times 1/2 squared plus 16 times 1/2 plus 480. Okay, this becomes negative 16 times 1/4. 16 times 1/2 is going to be 8 plus 480. This then becomes negative 4. Negative 16 times 1/4 is 4. Duh. Plus 8 plus 480. And that gives me an answer of 484 feet. So our cliff height was 480. He jumped up in half a second, and in half a second, he reached 4 feet from that. That's a pretty dull jump when you think about it, actually. Must have jumped out, so he got a little extra arc in his step. Okay? Then he's going to start falling towards the water. Speaking of that, Jason hit the water after how many seconds? So this is asking us for the roots, aka the zeros, aka x-intercepts. Okay? That's what it's asking for. So we're going to take this equation, set it equal to 0. Okay? And we are then going to take negative 16 out of it. The reason why, because if we do that, we get t squared, t squared minus t minus 30. And there are two numbers that when multiplied together give me negative 30, add together to give me negative 1, and those are 5 and 6, where 6 is the negative number. So that means my answer is going to, at least my setup is negative 16 times t plus 5 and t minus 6. Set equal to 0. And so we're going to have t plus 5 equal to 0 and t minus 6 equal to 0. Subtract 5 from both sides, we get t equals negative 5. And so add 6 to both sides, and we get t equals 6. Okay? We can't have negative numbers, so that's my answer right there. T equals 6. And that's how you fix number 1 up. So yes, the final answer for C is 6 seconds. All right, so for number 2, okay, this one's talking about a toy rocket. Now, something you understand about rockets. I'm going to say this, a couple things. Firstly, what goes up must come down. Okay? This rocket will have a lot of 2 for 1 answer. There will be 2 answers for 1. That's okay. It's a rocket. Secondly, it is launched vertically upward from the ground level, meaning that it's launching at 0, 0 and pretty much following along the side of the y-intercept and getting somewhere around here, okay? My point is that this rocket goes up very fast, and its y-intercept is 0. Why? Well, because it's starting at origin, which is why there's no C right here. Okay? Because it starts at origin. So the first question is, how long will it take the rocket to return to the ground? Well, first of all, it started at 0, 0. So all we need to worry about is when height equals t, when the height of, how long will it take for it to reach a height of 0? So h of t equals 0. At what height will when height is, oh, sorry, I'm saying that all wrong. Let me come in again. What time will the height be of the function? Basically what that's saying. I know it doesn't make any sense, but that's basically what it's saying. That height being equal to 0, but it doesn't know what the time is. So we got to set it equal to 0. And from that, we get the function equation set up of 0 equals negative 16 t squared plus 128t. Okay? And we are going to, first, we can't factor this because we don't have a c, right? We can't do it. But what we can do is we can factor things out. So we're going to pull negative 16t out, and we get t minus 8 equals 0. Both of these need to be then split and set equal to 0. So we'll have negative 16t equals 0, and t minus 8 equals 0. Divide by 16 from both sides, and I get an answer of t equals 0. Okay, but that's where it started, didn't it? Yeah. So that's not going to help us at all. We don't want that. What we want is this. Add 8 to both sides, and that number, t equals 8 seconds, that's my answer. Okay? Now, the next question. After how many seconds will the rocket be 112 feet above the ground? So now we do have a c, because our c just got moved from 0 all the way up here. So basically, here's the ground, here's the y, here's my height indicator, and here's where the rocket was. So he flew up, and then he flew down and hit the ground somewhere over here, right? But we just moved the ground from here up to here at 112 feet, and we want to know what's going to happen. Now, notice something. There are going to be two answers. Right here and right there. Because we are no longer against the ground. We will now have another intercept for the x. We've basically shifted our horizontal line up 112 feet. We have a new y-axis, basically. Sorry, not y-axis. A new x-axis, basically. My bad. Remember back to Unit 1 where we did all that. Okay, so now that we have that information, what we need to do is we need to set it equal to 112 feet, the function. So we have 112 feet. So at the height of what? So at that height, what are the times? That's basically what that's saying. So at the height of 112 feet, what are the times? So we're going to set that equal to negative 16t squared plus 128. Excuse me. 128t. Then we're going to subtract 112 from both sides. And lo and behold, we have 116t squared plus 128t minus 112. That's a function we can work with. In fact, we can actually factor it. If we pull out negative 16t, we get... No, sorry, just negative 16, not t. Not t. T needs to stay. My bad. I was thinking back to a. We pull out negative 16. We get then t squared minus t minus 30. That's factorable. Okay, think back. We just did this one problem earlier. Oh, wait, am I looking at the wrong? I'm looking at the wrong line. Oops. Okay, my bad. I factored that wrong. Okay, so we do need to pull 16 out, but I was looking. I had a very, very big dyslexic moment. Okay, my bad. So we have t, and we have t squared minus 8t plus 7. That's better. Okay, 16 comes, 128 is 8, obviously. I should have seen that earlier. So 128 out of 16 out of 128 is 8, and then 112 out of 16 is 7. right? So from all that mess, we get 0 equals negative 16, t minus 7, and t minus 1. Okay? We then would get t equals, so we factor this mess out, that's what we get. Then we have t equals 7 seconds and t equals 1 seconds. And both of these are your answers. Okay? Now, C and D are basically the first, just like A and B in the first problem up here. Identical question, basically, just different numbers. Asking how long will it take the rocket to maximum height, and what is the maximum height? Same thing before. Opposite of B over 2A, plug in what we know. We have negative 128 over 2 times negative 16. We get negative 128 over negative 32, and that gives me 4 seconds. There's my maximum height time. We take the maximum height, plug it back into the original, not the one with 112, the original. So we have h of 4 equals negative 16 times 4 squared plus 128 times 4. Okay? And if you simplify that, you should get 256 feet. Okay? So there are the first two problems. Okay? The rest are you should be able to do on your own. Same principles apply as we've been discussing so far. All right, good luck.